So hello everyone, myself Priyanshi Mishra and my topic is stable and unstable equilibrium. So first let us understand what is stable and unstable equilibrium. So if a body is in equilibrium under the action of system of forces and it is slightly displaced from its position of equilibrium, then it may remain in equilibrium in its new position or try to come back to its original position of equilibrium, or it may have the tendency to move further away position of equilibrium. So these cases respectively are known as neutral equilibrium, stable equilibrium and unstable equilibrium. So now let us see the energy test for the stability. So now let us see its statement. So in a position of equilibrium of a body under the system of conservative forces, the potential energy is either maximum or minimum. Then if the potential energy is maximum, then equilibrium is unstable, and if the potential energy is minimum, then the equilibrium is stable. Now we know that if a body is in equilibrium under the action of conservative forces, then their potential energy is either maximum or minimum. And we also know that by the principle of conservative of energy, the energy cannot be created or destroyed, that is potential energy plus kinetic energy is equals to constant. Now body is slightly displaced by the position of maximum potential energy, so its potential energy decreases and kinetic energy increases, so the body moves further away from the position of equilibrium. Now this shows that the equilibrium is unstable for maximum potential energy. Now further, if the system is slightly displaced from the position of potential energy, the body moves and potential energy decreases and kinetic energy increases. So here what will happen, it will try to come back to the state of minimum potential energy, because the potential energy cannot be lower than minimum potential energy. Hence for minimum potential energy, equilibrium is stable. Now let us understand what is center of gravity. In short form we can write it as COG. So it is the point at which the total weight of the body is supposed to be concentrated is known as center of gravity of the body. So center of gravity of the body is different surfaces. So center of gravity of a sphere whose radius is a is at a distance a from the point of contact, that is position of rest. So in this figure let us see the center of gravity of a hemisphere of radius a. The radius of this hemisphere is a from the curved surface is at equal distance to center of gravity this. So the center of gravity of this is 5/8a. Now let us see the second figure. So the center of gravity of a hemisphere of radius a from the flat surface at a distance equal to COG is center of gravity is 3/8a. So we will understand this from this figure. Center of gravity will lie here. Now center of gravity of a cone, so of height h is at distance h/4. So here this is the cone and the center of gravity is here and this is the height, so this will be h/4. Now center of gravity of a cube whose edge is a is at a distance a/2. So this is the cube and this we will understand by here. So this whole is a, so this half will become a/2. This, so let G1 and G2, here G1 is this and G2 is this, are the center of gravity of lower body and upper body having weight W1. W1 is the weight of the lower body and W2 is the weight of the upper body, and G is the point where total weight of the body to be concentrated, and this is the point where the weight of this and this body, both the body is concentrated. Then the center of gravity of combined body is W1 this we will take w1 dot a g1 plus w2 dot a g2 upon w1 plus w2. So this was stable and unstable equilibrium. Now let us move further. So let us see the conditions for stability and instability. So condition of stability and instability for sphere. So here we have three cases. Case 1, this is the sphere and this is the center, and the center of gravity will lie here. So let us understand this. The center of gravity lies on the vertical line of the point. Like this is the sphere. So this is the center, and the center of on the vertical point of contact, and it is below the geometrical. So the center of gravity will be here. This is the center and the vertical line to the point of contact, and it is below the geometrical center. Then the condition is known as stable equilibrium. So if in a sphere the center of gravity lies below the point of contact and below the geometrical center, then the condition is called stable equilibrium. Because if it is slightly displaced from this position of equilibrium, then it is trained to come back to its original position due to less turning effect. Now let us see case 2. So in this we will take a sphere and center of gravity will lie above the geometrical center. So let us see what will happen. So the center of gravity lies on the vertical line to the point of contact and is above the geometrical center. Then it is the condition of unstable equilibrium. So this will become unstable due to the maximum turning effect. Let us see this in detail. So because if it is slightly displaced from the position of equilibrium, if the center of gravity is above the geometrical center and it is slightly displaced from the position of the equilibrium, then it has the tendency to move further away from the position of equilibrium. So due to the maximum turning effect, it is known as unstable equilibrium. Now let us see one more case. Case 3. So if the center of gravity and the geometrical center of a body are coincide, then if it is slightly displaced, then it will remain in equilibrium and there will be no turning effect. So if the center of gravity and the geometrical center lies at the same point, and then if the body is displaced, then it will remain in equilibrium because there will be no turning effect. So this is known as neutral equilibrium. A test for stability of nature. So we know that for stable equilibrium, center of gravity must have minimum height, and for unstable equilibrium, the center of gravity have maximum height from the position of rest. So let z be the height from the position of rest to the center of gravity of the body. Then it is the function of theta, which represents position of the body, that is z is f theta. So if the body will be in equilibrium, if z is either maximum or minimum, then dz upon d theta will be 0. So if theta will be alpha, beta and gamma, so let us see what will come. So if theta is equal to alpha, then if d square z upon d theta square is greater than 0 at theta is equals to alpha, then z will be minimum, which means height is minimum and equilibrium is stable. Now if d square z is smaller than 0 at theta is equals to alpha, then z is maximum and equilibrium is unstable because here height is maximum. So let us take one example. A body consisting of a cone and hemisphere on the same base rests on a horizontal table. Then the hemisphere being in contact with the table. Show that the greatest height of the cone, the greatest height of the cone is 0 at theta is equals to alpha. Then z will be minimum, which means height is minimum and equilibrium is stable. Now if d square z is smaller than 0 at theta is equals to alpha, then z is maximum and equilibrium is unstable because here height is maximum. So let us take one example. A body consisting of a cone and hemisphere on the same base rests on a horizontal table. Then the hemisphere being in contact with the table. Show that the greatest height of the cone, so that the equilibrium is stable is under root 3 times the radius of the hemisphere. So here we will consider, let r be the radius of the hemisphere and h is the height of the cone. Then g1 and g2 are the center of gravity of hemisphere and cone respectively, and weight is w1 and w2 respectively. So let g is the center of gravity of combined body and h is the height from the point of rest to the center of gravity. So here r is the radius of hemisphere and capital R will become infinity. So r is equals to r and h is ag. So w1 ag 1 plus w2 ag 2 upon w1 plus w1. So this w1 will become mg. So this will be mg plus mg 5 upon 8 r plus m2g r h upon 4. So here g ag is, the value of ag2 is r plus h upon 4 and the value of ag is 5, ag1 is 5 by 8 r, and here this will be m1g plus m2g. Now h is equals to m1, we will cancel out this g, so this will become 5 upon 8 r plus m2 r plus h upon में 4 m1 plus m2. So this m1, the value of m is rho v. From here we can see that, so this will become v1 rho 5 upon 8 r plus v2 rho r plus h upon में 4 upon v1 rho plus v2 rho. So the value of v1 is h is equals to 2 by 3 pi r cube 5 upon 8 r plus 1 upon में 3 pi r square h r plus h upon में 4 upon 2 by 3 pi r cube plus 1 upon में 3 pi r square h. So from here we will take 1 upon 1 by 3 pi r square h common from here and from here. So 1 upon 3 pi r square. So inside it is left 2r into 5 upon 8 r plus h r plus h upon 4, and from down if we will take common then it will be left 2r plus h. So this will be cancelled out and this 2 will cancel out from here. So this will become 5 upon 4 r square plus h r plus h upon 4 upon h plus 2r. So further we will solve it. So we will get h is equals to 5 upon 4 r square plus h r plus h upon 4 whole upon h plus 2r. So we will consider this equation star. Now h is equals to 5 r square plus 4 hr plus h square 8r plus 4h. So we will take this denominator up and this value, the value of h will become this. So for a stable equilibrium 1 upon h is greater than 1 upon r plus 1 upon capital R. Here lower body is flat, so r becomes infinity. So 1 upon h is greater than 1 upon r, so h is smaller than r. So we will put the value of this h from here in this equation. So this will become 5r square plus 4hr plus h square upon 8r plus 4rh less than r. So this will go this side, so this will become 5r square plus 4hr plus h square is less than 8r square plus 4r square h. So from here this whole will get cancelled out and here the value will be left, h square is less than 3r square. So h square is less than under root 3, h square is less than 3r square, so h is less than under root 3r. Hence the maximum height of the cone is under root 3r of radius of hemisphere for stable equilibrium. So thank you.